So this is again the problem related with the Kirchhoff's law. So here you have the batteries, the two potential and two loops. And you should be able to use the Kirchhoff's first law and the second law to solve for the currents into each components. Okay. So now let's call this as an I1. This current is an I1, and we call this current I2, and call this current an I3. And we can call this an R1, R2, and R3. And you can assume the direction in any direction you like to. It's entirely up to you. And the loop direction, you can again choose any direction. It can be clockwise or it can be anti-clockwise. I'm just choosing this direction, anti-clockwise. And I'm also again choosing for the anti-clockwise direction. And as I was saying, you can choose the direction you like to. It's entirely up to you. Now, loop 1, this is called, let's say, loop 1, and this is called loop 2. First, write out at this point, what you see here. The total incoming current has to be equal to the total outgoing current. At this junction, this is incoming current, and I3 and I2 is outgoing current. So what I can write is I1 is simply equal to I2 plus I3. I2 plus I3. This is called the Kirchhoff's first law, or first rule, or called the current rule, or the junction rule, whatever we call. Now let's talk about the loop 1 now. Loop 1. So what does the loop 1 tell you? So if I look the loop direction, it is going from negative to positive. If it is going from negative to positive, we call this as a positive potential. And now here, the loop direction and the current direction are parallel. It is going in the same direction. If it is going in the same direction, we take it as a negative. And R1 value, what's the value of this resistance? This is 4 ohm. Okay, so this resistor is 4 ohm. So what I have is 4 times I1. That's the potential across this one. Okay, this is the I1 R1. I do not know I1, but I know R1. This is I1 R1. Now for here, again the loop direction and the current direction are parallel, so I'm taking that as a negative. And now this is equal to I2 times 7, or called 7 I2. This is equal to 0. Let's call this your first equation. This is your second equation now. Okay. Now in loop 2. Loop 2. If you look at the loop 2 here, the current is going from negative to positive. We call that as a positive voltage. Here these two are now anti-parallel for this case. For anti-parallel, we call as a positive, and this is equal to 8 times I3. Here again, it's opposite direction. So we have 4 times I1 plus 4 I1. This is equal to 0. Okay. See, this equation has I1 and I2. This has I1 and I3. So what I can do, I'll just solve in order to have the same variables. Okay. So from equation 1, what I can do now, 9 plus 8, I3 can be given by I1 minus I2. This is from first equation. I'm plugging equation first into equation 2. And 4I2. 4I2, this is equal to 0. Okay. So here you see I3 is simply equal to I1 minus I2, and I'm plugging this value into this equation. 8 times I1 minus I2 plus 4 I1. Why I am doing this? Just to make the two variables in terms of I1 and I2, and we can solve easily. So now 8 I1 plus 4 I1 is 12 I1 minus 8 I2. This is equal to 0. This is equation 3. Okay. So again, you can use this symbol lab to solve this equation. So go here. Again, just again showing this one, symbol lab, and type your equation here. So my first equation is this equation, 12 minus 4I1. So I'm just typing here, 12 minus 4x minus 7 y, this is equal to 0. I type this equation now. Now I'm going to type this equation, 9 plus 12, 9 plus 12x minus 8y, 8y, this is equal to 0, and hit enter button. So this is the equation. I typed it, and here is the solution. The solution I got, the x value, which is equal to I1, is equal to 33 divided by 116 amp, and I2, what I got is 45 divided by 29 amp. Okay, and now, and I can use this equation one more time to get I3, and I3 would be simply equal to I1 minus I2, I1 minus I2. So 33 divided by 116 minus 45 divided by 29. If we solve this one, you'll get the negative 1.37 ampere. 37 ampere. That's all the answer you get. What does the negative sign mean here? Let me explain this one. What does the negative sign mean? The negative sign simply means here the current is in fact not flowing this way, but it is flowing through this way. That's all it means. The direction you have chosen is the opposite to the actual flow of the current. So the current in fact is flowing this way. That's what the negative sign means here. Okay.